All right, I had a question on this, which is 87A, B, and D. And I just wanted to kind of go quickly over what I would do for each of these problems. So the first one is saying the region between these two curves and it's rotated around the y-axis. And so what I notice immediately, because I've been doing this for a while, is if I draw a line that's perpendicular to the y-axis, then it goes through 2 points that are on the same function, right? Which normally what I want to look at is going perpendicular. Like, so normally I would want to change this into functions where it's x as a function of y. However, because I noticed that, then I think this is the situation where you would want to use shells, cylindrical shells. And when you're using cylindrical shells, you're picturing each of these cross sections when you rotate this thing around, forming a cylinder. So like this would be an empty cylinder, right? And then the second one, I don't know if I can really draw it, but it's going to be this cylinder here with an empty cylinder in the middle. And so I'm going to use the cylindrical shells method. I'm going to need to go from the integral from, it looks like 1 to 6 of 2 pi RL. So this is going to be 2 pi. I'll put a 2 pi out here. And this cylinder, what's the radius of it? Well, the radius of it is going to be x, right? And what's the height? The height is going to be x plus 1 minus x squared minus 6x plus 7. I think it's going to be this, whatever y1 minus y2. And I may have made a mistake when I converted that. I don't think so, but it's going to be that's the basic way that I would look at doing that one. In the next one, it's a similar type of question, except now we're rotating it around y is equal to -3. And so I can think of the cross sections are going to be washers here. So when I rotate this around, I'm going to get an inside circle and I'm going to get an outside circle. So I'm going to have the integral as x goes from 1 to 6. What's the outside circle going to be? Well, it's going to be x plus 1 plus 3, or x plus 4 squared minus, and there's a pi on the outside of it. And then what's the inside of the circle going to be? It's going to be x squared minus 6x plus 7 plus 3, or plus 10 squared dx. That's how I would do that one. And then this next one is like I would call the trickiest problem in all of these things. I used to put one like this on the test, but I didn't this time. But you're taking this region right here and you're rotating it around this axis. And so you actually have to to do this one, you have to think of shells, but the shells are oriented in the opposite direction. However, what hopefully if it may not appeal to your geometric intuition, it appeals to your algebraic or analytic intuition. If I change all these, if I flipped the x and the y and all these things, I'm going to basically be rotating this picture and I'm going to be dealing with the same type of scenario. And I think it's going to be more standard to the way that we normally look at things. So that's what I did in the second picture. And I'm rotating it around this axis now. So I have this shape. And so each x value is going to be a cylinder like this. So what would that formula be? Well, I'd have to figure out where they intersect. So where does x squared plus 1 equal to negative x squared plus 3? 2x squared equals 2. X is equal to plus and minus 1. Okay, that was easy. So now I'm going to go the integral from negative 1 to 1. These things are each going to be cylinders, so it's going to be 2 pi times, and then I think it's going to be 2 minus x, okay, is how big the radius is, times the height, and the height is going to be negative x squared plus 3 minus x squared plus 1 dx. I think that's what that is. And you could simplify it from there, of course.